Hi everyone, my name is Ardiani Shazwin binti Haizal. My matrix number is D202010949696.
Hello everyone, my name is Jurida binti Maulana. My number matrix is D2020109570.
Hi, my name is Nur Alia Saleha binti Fauzi. Matric number D202010956616.
My name is Nurul Atika binti Masaha. Nometric D202010956673.
Hello everyone, my name is Jorina and I'm gonna explain how to find orthogonal basis by using Gram-Schmidt formula. First of all, this is the matrix given from the question, and from this matrix we will get three vectors. But to turn the matrix into vectors, we need to transpose the matrix first. After we transpose, we need to assign a new like this, so it will select the first row of VT1 and assign it to VTE1, and we need to repeat the same process for V2 and V3. After that, we'll use the Gram-Schmidt formula to find U sub 1. The formula for U sub 1 is vector U sub 1 is equal to the vector V sub 1. And then we will compute U sub 2, which is this is the formula. Vector U sub 2 is equal to vector V sub 2 minus a scalar multiple of vector U sub 1, where the scalar multiple is the quotient of the dot product shown. And then after we get the U2, we need to assign it as UE2 equal to transpose U2 in the bracket 1, so that it will extract the first row and assign it to the variable UE2. So this allows us to store and refer to the first row of the transpose matrix for further calculation, which is to find U3. And then to find U sub 3, we will use the formula vector U sub 3 is equal to the vector V sub 3 minus a scalar multiple of the vector U sub 1 minus a scalar multiple of vector U sub 2. And after we get the answer, we need to transpose it again, so that it will turn into vector and it can read for the first row, so that it can read that as a whole. After that, we turn it into matrix form and we will get the final answer for orthogonal basis, which is 2, 7, 4, 3, 102, 22 over 39, negative 80 over 39, negative 39 over 39, 48 over 13, 2000, 459 over 1099, 1157 over 2198, negative 800 over 1099, negative 3841 over 2198. So this is the final answer for orthogonal basis.
Hi and Assalamualaikum. So for this part is the continuous from orthogonal basis, which is orthogonal basis. So, the given expression here, A, represents isometric. We have 2743, 3.128, negative 2.051, negative 0.744, 3.692, 2.235, 0.526, negative 0.727, and lastly, negative 1.747. So, matrix A has 3 rows and 4 columns. We have 3 rows and also 4 columns. The first row of the matrix A is 2743. We represent as U1, which is U1 represent as a vector. So U1, which is a vector and comes from the first row of the matrix A, we got 2743. And U2, which is vector U2, is the second row of the matrix A, 3.128, negative 2.051, negative 0.744, and lastly 3.692. And the same as U3, we got it from the third row from the matrix A. So, the matrix A has 3 rows and 4 columns, which means that it is 4 by 3 matrix. Each element in the matrix represents a value at a specific position with the matrix. So, from the next one, which is normalize. Normalizing is one of the requirements for a basis to be orthonormal is that each vector has a length of 1. We normalize each vector in the basis by dividing it by its norm. By dividing each vector by its norm, we make sure that vector has a length of 1, satisfying the orthogonality condition. So, for the first one, we norm vector u1, and we got the answer here is square root of 78. Next one, we normalize u1 by u1 dividing with norm u1, and the answer we got is this: square root of 2 over 3 over 39, 7 over square root of 78, 2 times square root 2 over 39, and lastly square root 3 over 26. For the next one, which is u2, we norm our vector u2, and we got the answer 5.30805. So next, we normalize u2 by u2 dividing with norm u2. We got the answer 0.589294, negative 0.386394, negative 0.140164, and last one 0.695547. Lastly, for u3, we norm our u3 and we got the answer 2.9753. And then we normalize u3 by u3 dividing with norm u3. So we got the answer 0.751184, 0.176789, negative 0.244345, and lastly negative 0.587167. And then I denoted P is matrix form of normalized U1, U2, U3. So P equals to matrix form normalized U1, okay, normalized U2, and lastly normalized U3. And the matrix form that I got is like this. Represents like this. After that, after I got it in the matrix form, I find P in P transpose to change to interchange its row and column. So, to write it like this, P equals to transpose the matrix here, transpose matrix, this matrix, and we got the answer like this. So, I denoted again Y as a new matrix form, which is we already transpose the matrix, and the answer will be like this. So, we have the answer is square root of 2 over 39, 0.589294, 0.751184, 7 over square root of 78, negative 0.386394, 0.176789, and 2 times by square root of 2 over 39, negative 0.140164, negative 0.244345, square root of 3 over 36, 0.695547, and lastly negative 0.587167. So, this is orthonormal basis. So, that's all from me. Thank you.
After done finding the orthogonality and orthonormality of the matrix, next we are going to find the value of x. X is equals to R inverse times Q transpose times with B. So, first we need to find the value of Q transpose. Next, by using the value of Q transpose, we find R equals to Q transpose multiple with A. Lastly, we can get the value of X by multiplying R inverse with Q transpose and matrix B. Then, by looking at the coding from Wolfram Mathematica that I have already run, first of all, I denote R equivalent to Y for my coding. Then, by using command of Y equals to transpose orthogonalize transpose A, we will get Y equals to the value shown in diagram of matrix Y. Next, we are going to find the value of R using command R equals to N transpose Y multiple with matrix A. From that, we will get the matrix value of R equals to 8.83176, 12.6815, 10.5302, negative 1.11 times 10 to the power of negative 16, 5.30844, 7.43374, 00, and lastly 2.97571. After we get the value of Q transpose and R previously, then we will be able to find the value of X by using command of X equals to N inverse R multiple with transpose Y and matrix B. Thus, the final answer that we get from Mathematica is the value of X equals to 1.51986, negative 1.10846, and 1.07096. Thank you.
Hi everyone, so now I will show you how to find the least square using QR factorization. So first thing first, we have to know this equation, which is A is equals to QR. Q is orthonormal basis and R is upper triangular matrix. So if we want to find orthonormal basis, we have to find the orthogonal first. So then we have to use Gram-Schmidt. But first, let's take a look at the question given. So right now we have A matrix, which is 4 by 3 matrix, and we have this 4 by 1 matrix, call it as B. So to start the Gram-Schmidt process, I will take this first column as my V1, and then the second column as my V2, and the last column as my V3. So here I write V as my original basis and U is my orthogonal basis. To find the U, I will use this formula. Okay. Let's compute for U1, U2 and U3. So for U1 is equals to V1. So I just take the original basis here. For U2, I will take V2, this V2, minus with V2 multiply with U1 divided by U1 squared, and I will multiply with U1, and then I will get this answer. For U3, I use this formula too, and then I will get this answer. And then I have find the orthogonal basis for call A, which is my U1, my U2, and my U3. And then I can find my orthonormal basis. So for orthonormal basis, I will use this formula. So for the denominator, I will sum all of the elements in the matrix and I will square root the answer and it will give this answer. And then I will divide with U1 matrix and then I can write this answer either in fraction or in decimal. So same goes with U2 and U3. Then finally I have find the orthonormal basis, which is my Q. So the first column is my U1, the second column is my U2, and the third column is my U3. And then back to the main equation, I have A is equals to QR. We have to find R. Just now we have find Q. So now we have to find R. So we modify this equation until we will get only R. So the final equation after modified is Q transpose multiply with A. And then this is my Q transpose. I will multiply with A matrix. And it will give me this, which is my R is a square matrix, 3 by 3 matrix. And then we have to use AX is equals to B. So I will modify this until I will find only X. So I have this formula. So right now what I have to do is I have to find R inverse. I will multiply with Q transpose. Then I will multiply with B. So to find R inverse, I have to use this formula, this common formula to find inverse. So the determinant of R is 139.519, and the adjacent of R, after I get the answer, I have to transpose this matrix, then I will find the real adjacent R. So to find the R inverse, I will multiply 1 over the determinant, multiply with adjacent R. I will get the final answer is this, the final answer for R inverse. So for the final step, finally, we can compute the X, which is, this is my R inverse, this is my Q transpose. I will multiply this one first. After I get the answer, so this is my answer for R inverse multiply with Q transpose. Then this is my B, according to this equation. After that, this is my final answer. So thank you.